to the lecture series on mathematical methods in physics. Today we are going to start with the chapter curvilinear coordinate system. Curvilinear coordinate system. So this is C. So in order to understand what is a curvilinear coordinate system, first we need to understand what is a coordinate system and why do we need coordinate system. Why coordinate system is needed in physics. So whenever we encounter any physical problem, we use something for reference. Like if you are solving the problem in gravitation, you are solving problem on electrostatic field, you are solving problem on temperature, you use some reference point, and with respect to that reference point you tell the temperature. Now imagine you are standing in a room. Okay, this is room and this is floor of the room, and here is a ceiling fan. So, okay, now I ask you what is the position of ceiling fan. Then you might tell me that it is at some z distance from bottom, some y distance from this wall, and some x distance from another wall. So what you are doing, you are basically using the walls and the floor of the room as a reference. Similarly, in physics we use coordinate system to locate the point. So we will define a coordinate system first. So definition is like this: reference system. Here we use a reference system as these walls and the floor of the room. Reference system used to fix a position of point in space. So we use a reference system and we fixed a point in a space using that reference system. Now let us move further and see which type of coordinate systems are there. So there is first Cartesian coordinate system, second is say spherical coordinate system, and third is cylindrical coordinate system. So these three are the most commonly used coordinate system, and in general there is a coordinate system which is curvilinear. So this is a general coordinate system, and cylindrical, spherical, Cartesian are most commonly used coordinate systems. We will start with the Cartesian coordinate system. Okay, let us start with the Cartesian co-ordinate system. Okay, so in Cartesian coordinate system there are three axes. So these are three axes. So x, y, and z. These are the names of the axes, and these axes are mutually perpendicular to each other. These axes are mutually perpendicular to each other, and second thing is the unit vector along this direction is constant in magnitude and direction. Vector or vector along in this direction, that is say y direction, there is vector j cap. Along x direction there is a vector I cap. Along z direction there is a vector k cap. These are the unit vector which are denoting the direction of those axes. Somewhere you might see that along x-axis there is x cap, y-axis y cap, and from z-axis z cap. These are the unit vector along the again x, y, z coordinates. I am assuming that you know that this cap is using for unit vector, and if you put a bar, it is just random vector which might have or may not have the magnitude 1. Okay, that is unit. Now suppose there is some point in a space, and this is origin, this is point P, x dash, y dash and z dash are coordinates of point P. Then I can write the position vector of P bar or point P. Okay, so position vector of OP bar, I will call it R bar. Okay, R bar joining a point origin. So coordinates of origin are 0, 0 and 0, and point P, I can write it like this: x I cap. So I am using x dash, so I should put x dash plus y dash j cap plus z dash k cap. Now if I ask what is the magnitude of this vector, then we can write it like this: mod of r bar is equal to root of x dash square plus y dash square plus z dash square, right? So this will be the magnitude of vector r bar which is joining origin, this is origin, and point P. Now let us move further. There is another concept called as coordinate lines, co-ordinate lines and net surface. So coordinate line and coordinate surfaces. So I will draw again a coordinate system. X axis, y axis, z axis. I will draw a plane parallel to zx plane. Okay, so this is my zx plane. You can see the plane formed by x axis and z axis, which is passing through x and z axis, that is xz plane, and I am going to draw a plane perpendicular to that plane. So these points say y dash. Then I can write the equation of plane as y is equal to y dash. This is the equation of this plane. I can draw a plane parallel to xy plane. So this is a plane parallel to xy plane. This plane is going through a z axis at point z dash. So equation of plane I can write z is equal to z dash. You can observe one thing here. On this plane, I'm not going to name them because it becomes complicated. So on this plane, y is equal to y dash. Only y coordinate is fixed. Other coordinate x and z are varying. If you take this point, it have same coordinate y is equal to y dash. Okay, this point, and the other coordinate will be different. If I take this point, only y is equal to y dash is constant, and others are different. Okay. Similarly, if you look at the plane z is equal to z dash, you will notice that only z dash is a constant on this plane. Other coordinate x and y are varying. Now so this dotted line is a line of intersection of plane y is equal to y dash and z is equal to z dash. So this line we will call as a coordinate line and these planes or the surfaces are coordinate surfaces. Okay, the interesting thing is that if you draw a third coordinate surface, you will get more lines. Okay, so I will try to draw it. So suppose the third surface is passing through this point x dash. It will be parallel to z y axis or zy plane. So if I draw a surface like this, okay, so this surface is going to intersect somewhere here to the plane. We'll name this plane x is equal to x dash here, and it will intersect another face here, right? So these are coordinate lines. On one coordinate line you can see, suppose I take this coordinate line which is parallel to x-axis. So on coordinate line I will name it, say, okay, A, B. On coordinate line AB, you can see that x is varying, and y and z are constant, right? So this is what I can see on coordinate line. So, and on plane, if I take plane z is equal to z dash, only z dash is constant, or z is a constant, right? Or you can say z is a constant and other coordinates are moving. Okay, so that is the difference between coordinate line and coordinate surfaces. Their different properties. Now we will move to the next coordinate system. I hope this is clear. Okay, if you want to understand this, you have to draw it by yourself, and then you have to see which plane is intersecting where, what is the equation of plane, so it will be more clear to you. Now we will go to the next coordinate system, that is spherical coordinate system. So I should take it down, co-ordinate system. Okay, so spherical coordinate system, as name suggests, spherical coordinate system is used in problems where there is a spherical symmetry. So there are three coordinates in spherical coordinate system: r, theta and phi. Okay, r coordinate is a distance of point from the origin. So this is, suppose, my point P, then this distance is r coordinates, and you can see I have to draw a sphere of radius r, even though it don't look like sphere, it is a sphere. Okay, and you can see it is on plane, that's why it look like a circle, but we are drawing it in 3D. I mean, we are drawing it in 2D, but you have to imagine it in 3D. So you will see a circle of radius r. Second coordinate is theta, so which is angle made with a positive z direction, okay, or z axis. I should name here also x, y, z. And now this is my point P, and this is angle theta with z axis. You can see if I draw a circle, on this circle or on this locus of point, you will see that angle theta is constant. It is, there is a third one, third coordinate, which is phi. You can see r, theta, and now we will draw for phi. This is a point P, and now if I take a projection of point P on xy plane, and if I join it with origin, then you will get some angle phi. So it is angle made with x-axis, and the you can look it like a shadow of point P, where you will get the point P, shadow of point P on xy plane, and you have to draw that point and join that point to origin. Then you will say P dash, then angle between x-axis and the line joining the point P dash and O. Okay, that is our third coordinate phi. Now you can see here on r direction only r is varying. Okay, so it's in similar way you can look for the coordinate lines and coordinate surfaces. Now we will move to the next point. Our next point is relationship between coordinate line, not coordinate line, Cartesian coordinates next, and spherical coordinates. Which are the Cartesian coordinates? X, Y, Z are Cartesian coordinates, and which are the spherical coordinates? R, theta, and phi. So more general, or more particularly I should say, spherical polar coordinate system. Polar coordinate system. Now I'm going to derive the relation between x, y, z and r, theta, phi. So this is, again we have to draw a coordinate system. This is x-axis, this is y-axis, this is z-axis. This is some point P in space. I'm joining this point to a origin O. Now you know this angle is theta. If I take projection of that point on xy plane, this angle is phi, this distance is r. I will call this point as n. If I join this point to the x-axis and again to a y-axis, I will call it m, I will call it L. Okay, now I want to write expression for x. So x coordinate, you can see x means this distance, right? This distance is x, so OM is x. I can write OM in terms of phi. It will be, so I can write it as cos of phi is equal to OM upon ON. This implies OM is equal to ON cos of phi. So I will put it here, ON cos of phi, right? Again I can write, you can see from the diagram, so I will call this point as some R. Okay, so ON and RP are nothing but same, so I can replace ON by RP cos of phi. Now in triangle ROP, okay, triangle ROP, you can see what you can see in sine of theta is equal to RP upon OP, right? This will give me RP is equal to OP sine of theta. Now this one I will use here, right? I wanted the value of RP, I found it here, so it will become X is equal to OP sine of theta cos of phi, which I can write as OP is R. So you can see this is OP and this is R. So it will be R sine theta cos phi. So this is a relationship between x coordinate and r theta phi coordinate. Okay, so from Cartesian to spherical, this is Cartesian coordinate and these are spherical polar coordinate system or coordinates of spherical polar system. Okay, now we have to go for another coordinate, that is which one? Y coordinates. So for that we have to use this diagram again as a reference. So I will put it here and we will write y here. So what we can see, y is equal to, so this is y axis and here you can see OL, so I can write OL. Okay. Again OL and MN are same, so I can write it as MN. Then you can see we are in this triangle OMN. I can write MN, I will write here directly. MN is ON sine of phi, right? Then you can see ON is parallel to RP, then ON and RP has same length, so I can replace it by RP sine of phi. Now in triangle ROP you can write RP as R sine of theta sine of phi, or I should write it like this, OP sine of theta sine of phi, and then further OP is R. So this is relationship for y coordinate. Now for z coordinate, z is equal to OR, right? OR, this is z. So I can write in triangle ORP, it is R cos of theta. So this will be for z coordinate. So I got the three relationship among y, x, y, z and r theta phi. We obtained the relationship between x, y, z coordinates. It was like this: x, y, z and r theta phi coordinates. So x was r sine theta cos phi, y was r sine theta sin phi, and z was r cos of theta. Now we are interested in obtaining relationship between r theta phi to x, y, z, between those. So basically I want to find the relationship between r coordinate and x, y, z coordinate, theta coordinate and x, y, z coordinate, and phi coordinate and x, y, z coordinate. Okay, so what I will do, I will take the square of x square, y square plus z square and I will add them. Now I will use these values here, so it will be r square sine square theta cos square phi, r square sine square theta sine square phi plus r square cos square theta. Now I can take r square common, then this will become, now you can see rather than taking r square common in first two terms I can take r square sine square theta common. So I will do that, r square sine square theta common, and then cos square phi plus sine square phi, and then there is r square cos square theta. So you can see cos square phi plus sine square phi is 1 sine square theta plus cos square theta, something like that. Okay, then r square sine square theta plus r square cos square theta. If you take r square common, you will get sine square theta plus cos square theta, whose value is again 1. So this is r square. So what I write from this is this: r square is equal to x square plus y square plus z square, which implies r is equal to root of x square plus y square plus z square. So I have obtained the value of r in terms of x, y, z coordinates. Now we will similarly work out for theta coordinate and we will work out for theta coordinate and phi coordinate. So what I will take a ratio of y upon x. Y was r sine theta sine phi, x was r sine theta cos phi. So you can see r get cancel, sine theta get cancel. I will land up with tan of phi. So this will give me the value of phi, which is phi is equal to tan inverse of y upon x. Now there is a theta coordinate is remaining, so we have this one is in terms of Cartesian coordinate system. I have obtained phi. Now it was like this: z is equal to r cos of theta. This was a relationship for z. I can write it like this: z upon r is equal to cos of theta. This one I am writing like this. I can take cos inverse, then it will become theta is equal to cos inverse of z upon r. It can be written as cos inverse of z to be as it is. R, I have obtained the value of r. It was x square plus y square plus z square. So theta is equal to cos inverse of z upon root of x square plus y square plus z square. So this is the value of theta in terms of Cartesian coordinate system. Now we will put a limits on this value, that from where to where it can go. So I will take first page. Here you can see r was like this: x square plus y square plus z square. So I will write r here, root of x square plus y square plus z square. This was the value of r. And the limit on r will be, r is the radius of that sphere, right? So r can't be negative, it will be 0 or always positive, so greater than or equal to 0. Phi was the angle made with the x-axis, so it can take value from 2 pi will be the highest value, then it will be the highest value, it will be less than 5, and it will be greater than 0. I'm not putting here equal to sign. The reason behind that is phi is ranging from 0 to 2 pi, and 2 pi and 0 are nothing but same. So in this interval I will include only one value, that is 2 pi I have included, so I don't need to include 0. Now for theta coordinate, theta is going to vary from 0 to, so theta is going to vary from 0 to pi, because you know it was angle made with z axis. So theta is like this, and it can go to here, right? So it is 0 here, it is 2 pi here, I mean pi here. Okay, so for today we will stop here. Thank you.